9.4, variation. There are three types we're going to talk about here. There's direct, inverse, and joint. And first we'll talk about direct. Direct is, well, just to give you the outline of it, it's the outcome increases or and decreases along the variable. All right, so a couple of examples of that. The smarter you are, the higher your grades. Or the opposite, the less intelligent, the lower your grades. Or the more you work, the more money you make. Or the opposite of that be the less you work, the less money you make. So just to kind of summarize it, whatever you do, the outcome is going to move the same direction. So if you do more of something, you're going to get more in return. You do less, you're going to get less out of it. All right, and the formula is either going to be solved for y, or we can rearrange it so it's solved for k. And I'm going to ask y'all to solve for k on all of these. And you may not always be solving for y, but that's usually the way we start out. So you can really use either one you want. But again, you'll have to solve for k every time, so you'll probably want to use this. And if you want to solve for the other variable, probably want to use this formula. K is what's called a constant of variation. They're kind of making a big deal of that on the new SOL. You'll see what that is more as you do some of these problems. It's just a constant that always stays the same. A lot of these are going to relate to physics problems and electronics, things like that. And if you've taken some of those classes, you'll understand some of those constants, where they come from. So let's try an actual example here. So let's say that if y varies directly as x, y equals 12 when x equals negative 3, find y when x equals 16. Okay, they're all going to be word problems. So we need to kind of figure out how to use them. First of all, you have a variable y. It's varying directly as x. Okay, so you've got your variables and you've got your variation. So direct variation, y equals some constant times x. And if we're solving for k, that constant equals y divided by x, because I can do the algebra here, divide by x, and I get this equation. And just to reiterate the point, the only way this works out, if x gets bigger, y is going to get bigger. If I plug a bigger number for x, y gets bigger. If I plug a smaller number for x, y is going to have to get smaller. That's how direct works. All right, so first thing, again, you got to find k. That's what I want y'all to do. So we want to figure out what k is going to be if y is 12 and x is negative 3. All right, well, if y is 12, x is negative 3, it's not that complicated. K is negative 4. So we have some kind of constant here that's negative 4. Again, a lot of your physics equations, electronics, things like that, you have constants that never change. Usually they're named after somebody important that discovered them. All right, well now, let's solve our other part. If we know y equals k times x, and now we know that k equals negative 4, we need to find y when x is 16. Okay, well, it's k times x, so negative 4 times 16 is negative 64. And that's it. Next type is inverse variation. The outcome changes the opposite of what you put into it in inverse variation. So a couple examples: the faster you drive, the less time it takes to get there. If you change this, the slower you drive, then the more time it would take to get somewhere. Or the greater your distance from an object, the smaller it appears. Okay. If you change that to less, the shorter your distance from an object, then the bigger it would appear. So whatever you do has the opposite effect on the outcome. Okay. The bigger your distance, smaller the thing looks. Or faster we're driving, less time. So faster speed, smaller time. Formula, in this case, y is k divided by x. The way that works is if k gets bigger, to keep everything balanced, y is going to have to get smaller. Or if x gets smaller, y would have to get bigger. Just think if you divide by a really big number, you're going to have a smaller outcome. If you have a pizza and you divide it into 100 parts, you'll get a really small piece. But if you divide it in 2 parts, you get a bigger outcome, bigger piece. All right. For k, constant is x times y in this case. So let's do an example. if r varies inversely as t, so again, underline your variables, we want to know how they vary and set up our equation. So r would be your constant over t. Or if you want to solve for your constant, which I'm going to ask you to do, then r times t. Okay? Well, if r is 18 when t is negative 3, then that's 18 times negative 3. That's negative 54. Okay, so k is negative 54. And if I want to figure out what r is going to be, well, r is going to equal that constant divided by my t value. And in this case, r is just going to end up being a fraction. You can try to reduce that, but it can't be reduced anymore. 11's prime, and it doesn't go into 54. It's pretty close to 5. It's 4.9 something if you want to get a decimal. The last type is joint variation. And that's when we have two outcomes, or our outcome is dependent on more than one variable, two variables, I'm sorry. So a good example, the price you're going to pay for produce is dependent on the cost of gas and the pay for truck drivers. So if you go to the grocery store and stuff's costing more, I'm sure there's other factors it could be, but a lot of it has to do with shipping. Every time gas goes up, it's going to cost you more at the grocery store. And if truck drivers start demanding more pay, then you're going to pay that too. So there's a lot of factors that go into most situations. So a lot of things are joint variation. Your formula is very similar to direct, so let me write that here. It's not exactly direct. I'll just put that tilde. It's kind of like direct. It's like direct with two variables. Same formula, basically. K is pretty much the same deal. Same formula, just with two variables. Because direct variation was y over x. This is y over x times z. All right. An example, suppose y varies jointly as x and z. All right. Well, that means that y equals k over x times z. Your constant is going to equal everything multiplied together. I did x times z because it's the order I had here. Well, we got to find the constant first. So this side, I don't know all my variables, so I'm going to use this one to find my constant. So find the constant if y is 16, z is 2, and x is 5. Well, that's 10, so that's 160. That's my constant. And I was supposed to find y, so y equals my constant divided by 8 times 3. Okay, so y is 160 over 24, and I could reach for the calculator at this point, but let's practice a little bit of our factoring. We know they're both even, so we can divide them by 2. That's 80 over 12, still even. That's 40 over 6, and still even, so 20 over 3. I think that's as far as I can take it. 20 over 3, or as a decimal, that'd be 6.6 repeated. And that's it. So go back and watch some of these short segments a couple more times if you need to get it, but that's all there is. Just plug it into a formula. I think you're going to find it a lot easier than most things in this chapter.